Parametric equations, part 2, eliminating the parameter, and also parameterizing pretty typical functions. So, eliminating the parameter is when we remove the parameter t to go back to y equals f of x. Now, of course, the parameter doesn't have to be t, but for us it typically is. So let's consider the parameterization x of t equals t plus 1, and then y of t equals 2t minus 1. Our goal, get rid of the t's. More than one way to do this. I'm going to look at this first part and notice that x minus 1 equals t. Pretty basic algebra. And so to eliminate the parameter, I could simply substitute in that t, which would give me y equals 2 times t, x minus 1, minus 1, or 2x minus 3. And we have successfully eliminated the parameter. In the last video, I did a problem like this, but it bears repeating because it is one of the more important ones. What if we had the parameterization x of t equals cosine of t, and then y of t equals sine of t? How can I get rid of the parameter? It's basic trick. All you got to remember is that cosine squared plus sine squared always equals 1 as long as the argument is the same. But cosine is x, so I have x squared. Sine is y, so plus y squared equals 1. And we have successfully eliminated the parameter t. Other type problems. This is not one of the big things in calculus, eliminating the parameter necessarily. One of the more common things is, what is or how do we find a good parameterization for a curve that we have? So let's consider the curve, which is actually going to be broken up into 3 pieces. So pretend you're an object starting at the origin and going towards the point 1, 0. I'll call that curve 1. Then, without stopping, you travel up the vertical segment. We'll call that curve 2, stopping at the point 1, 1. Well, not really stopping, but turning and going down the line y equals x from 1, 1 back down to 0, 0. What is a parameterization of the total curve? Well, the nice thing is that we can do a parameterization for each piece. Later on, when you have to do this for integration, like line integrals and similar, you can choose any parameterization. Any correct parameterization will work, so it's nice to choose a simple one. So let's choose something really simple for C1. Let's just let x equal t. On the curve, y always equals 0. But if I choose x to be t, this would be true on the interval from 0 to 1. You can check it. At t equals 0, you're at the point 0, 0. At t equals 1, you're at the point 1, 0. And that works. How about curve 2? Well, on curve 2, x is always 1. X doesn't change. And the y equals t. Or does it? What if I just want to keep going and order my time? And I say, now this is, say, from 1 to 2. Well, x equals 1 still works, but y equals t does not work. Because at t equals 1, I should be at y equals 1, but I'm not at y equals 0. So what if, instead, I do the parameterization y equals t minus 1? Does this work? Well, at t equals 1, y equals 0. At t equals 2, y equals 1. I'm feeling pretty good about that. So how about C3? Well, now both of them are changing. In fact, x is getting smaller, right? So let's say probably something minus t, because I'm going that direction. And y equals, we already said we're on the line y equals x. So if I can figure out what x is, I know what y is. And let's keep our time in order. So let's say from 2 to 3. So at t equals 2, x should be 1. What if I did 3 minus t? Certainly that works for this point over here. How about at t equals 3? Does x equal what I want? Yes, it does, because I'm back at the origin. And then y is 3 minus t. Is this the only parameterization? Absolutely not. I could have done other ones. I could have maybe made this one 2 minus t, perhaps. Does that work? No, that doesn't work. But there's certainly other ones that could have worked. So when you have the choice, I recommend choosing the simplest one that you can. So one more. What if we have a circle whose radius is 3? When the circle is 1, we just do x as cosine, y as sine. But how about this one? Well, it's pretty easy. If I divide everything by 9, and if I rewrite this slightly, x over 3 squared plus y over 3 squared equals 1. And I know that cosine squared plus sine squared always equals 1. Well, that tells me I could let cosine of t be x over 3. And sine of t be y over 3. Which means the parameterization could be x equals 3 cosine t and y equals 3 sine t. Side note, a similar thing also works for ellipses.